Good morning everybody. Myself Vishvendra, the founder of Optimal Success Trajectory. Today I will talk to you about speed of sound in a gas. So Newton first of all gave the Newton formula for finding the speed of sound in a gas, and he said that the speed is equal to root under E upon D, where E is coefficient of elasticity and D is the density. Later on Laplace corrected it and he said that propagation of sound in a medium is an adiabatic process because it's very fast, so it don't have any time to exchange heat with the surroundings. And after all the implementations and all the updations and after the correctness of the equation, he said that speed of sound is root under gamma p by rho or gamma RT by m, where gamma is the coefficient of adiabatic exponent, p is pressure, rho is density, gamma is adiabatic exponent, T is temperature, R gas constant, M is molecular mass in gram. So if we look for the graphical analysis, we can say that V is proportional to root gamma, so graph will be a parabola. V is proportional to root T, graph again will be a parabola. V proportional to root T, so if we draw the graph between V and root T, it will be a straight line. Whereas if we draw graph between V and root M, V and M, it will be a rectangular hyperbola. Whereas graph between V and 1 by root M will be a straight line. So you have seen that whatever you learn, make sure you learn in a proper and systematic way so that you can retrieve as and when needed. Thank you and have a nice day. Good morning everybody, myself Vishvendra, I am the founder of Optimal Success Trajectory. Let's discuss today the relation between velocity and position in SHM. Suppose a particle is undergoing SHM along the x-axis, its instantaneous position at any moment is x and the velocity is v. Let's try to find out the relation between these parameters. So let's suppose that the equation of SHM is given by x is equal to a sine of omega t plus phi. We know the relation between velocity and the coordinate as v is equal to dx by dt. So if we differentiate sine omega t plus phi, the answer will be omega cos omega t plus phi. So this will be the differentiation of sine omega t plus phi. We just square them. So we have v square is a square omega square cos square omega t plus phi. So it can be written as omega square a square cos square omega t plus phi. Now I can write cos square omega t plus phi as 1 minus sine square omega t plus phi. So we have v square is equal to omega square multiplied by a square minus a square sine square omega t plus phi. Now a square sine square omega t plus phi can be written as x square. Now taking the square root, we have v is equal to plus minus omega root a square minus x square. If x is equal to 0, then v will be plus minus omega into a, which is the maximum speed. X is equal to 0 corresponds to the equilibrium position. So we can say that a particle in SHM possesses maximum speed when it passes through the equilibrium position. Whereas if x is equal to plus minus a, then v is 0. Plus minus a refers to the extreme positions. So we can say that at extreme position the speed is 0. Now using this equation we can write v square is omega square a square minus omega square x square. So v square plus omega square x square is v omega square a square. Dividing the expression by omega square a square, we have v square upon omega square a square plus x square by a square is equal to 1. This is equation of an ellipse which can be drawn like that. So these points have coordinate a, 0, minus a, 0, 0, a omega, 0, minus a omega. Now area under ellipse is pi a square omega. If we take the speed means magnitude of velocity. So you just neglect the lower part and draw the upper part. So this will be the speed time graph and it is semi-ellipse. I hope you got the results. Thank you and have a nice day. Good evening everybody. Myself Vishvendra, the founder of Optimal Success Trajectory. Today we shall discuss about the speeds of gas molecules. Suppose a gas is present in a container, then Maxwell categorized different type of speeds for the molecules. He categorized the speeds as root mean square speed, average speed and most probable speed. So let's begin with the most probable speed. This is the speed possessed by maximum number of molecules. Suppose there are 100 molecules and out of which 60 molecules possess some speed. So the speed which is possessed by maximum number of molecules is the most probable speed. Maxwell through his experiments assign the value root 2 RT by m to the most probable speed, which is also equal to root 2 b by rho, which is also equal to root 2 kt by m. Here R is gas constant, m is molar mass in gram, T is the temperature, P is the pressure, rho is the density, K is Boltzmann constant, and small m is the atomic mass in AMU. Now talking about the graphical analysis of the parameters, the first relation is Vmp is proportional to root T. So if I draw the graph between Vmp and T, it's a parabola. Secondly, if I draw a graph between Vmp and M, it's a rectangular hyperbola. Secondly, we have for root mean square speed as root 3 RT by M, which is root 3 kt by M, which is root 3 p by rho. Similarly, the graph of Vrms versus T will be a parabola, while that of Vrms and M will be rectangular hyperbola. For average speed, we have V average is root 8 RT by pi M, root 8 kt by pi M, 8 p by pi rho. V average T graph is a parabola, V average M graph is a rectangular hyperbola. So this is the way how speed can be categorized. So you have seen that it's very easy to learn and retrieve information in your mind if you have stored that information in a systematic way. So work on the process that you use to learn information, to store information in your mind. Only then you will be able to retrieve it as and when needed, and you will be having a sharp problem solving skill. So work on quality of working. Thank you and have a nice day. Good morning everybody, myself Vishvendra. I am the founder of Optimal Success Trajectory. Let's discuss the molar heat capacity of a gas in a process. So suppose we have an ideal gas and we supply an amount of heat delta Q to the gas. As an impact of that, it performs our delta W and its internal energy increases by delta U. So using first law of thermodynamics, we can say that delta Q is equal to delta U plus delta W. Now, we know that delta Q can be written as NC delta T. Delta U is NCV delta T plus delta W. Equation of the gas is P V raised to power n is equal to K, which is constant. So we can say that P is equal to K V raised to power minus n. Now, the work done is integration of PdV from V1 to V2. So if we substitute the value of P, so P is Kv raised to power minus n in V2. So if we integrate that, K is a common, so it will come out, and the integration of V raised to power minus n will be V raised to power minus n plus 1 or minus n plus 1 from the limit V1 to V2. So after we substitute the limits, we get K 1 by n minus 1, V2 raised to power 1 minus n minus V1 raised to power 1 minus n. Multiply this expression by K, we have worked done as K V2 raised to power 1 minus n minus K V1 raised to power 1 minus n divided by 1 minus n. Now K is equal to P2 V2 raised to power n is equal to P1 V1 raised to power n. So if we substitute the value of K, then we have delta W is equal to P2 V2 raised to power n V2 raised to power minus 1 and 1 minus n minus P1 V1 raised to power n multiplied by V1 raised to power 1 minus n divided by 1 minus n. So here we take the base common and these n will cancel out and we will have P2 V2 minus P1 V1 upon 1 minus n. Using ideal gas equation, we can write P2 V2 as nRT2 and P1 V1 as nRT1. So taking nR common, we have delta W is equal to nR multiplied by T2 minus T1 divided by 1 minus n. Now T2 minus T1 can be written as delta T. So we have delta W is equal to nR delta T by 1 minus n. So if we substitute this value in this equation, we have NC delta T is equal to NCV delta T plus nR delta T by 1 minus n. Cancelling out n delta T from both sides, we have C is equal to CV plus R by 1 minus n. So this is a general expression. You can solve questions easily with the help of this way. So you have seen that whatever information you learn, make sure you learn that in a systematic way and in a way that you can retrieve during your test. Thank you and have a nice day. Good evening everybody, myself Vishvendra, the founder of Optimal Success Trajectory. Today I shall discuss about terminal speed. So whenever a solid sphere is moving in a fluid, then resistive forces acts on it because of the viscosity, and the buoyant force also act on the sphere, and after a certain time the body attains a constant speed which is called the terminal speed. We shall derive the expression for the terminal speed of the body. So let's look into the things with proper perspectives. So suppose this is a sphere and it's moving with the constant speed Vt. So the forces acting on the sphere will be buoyant force in vertically upward direction, resistive force in vertically upward direction, and weight in vertically downward direction. And we know that if velocity is constant, then acceleration will be zero. So net force will be zero. That means resistive force plus buoyant force minus mg is equal to zero. So we know the Stokes law that buoyant force is 6 pi into rb. Buoyant force is rho liquid vg, where v is the volume of the body. M will be rho solid into vg. So after all the calculations, we have the expression for terminal speed as 2g r square by 9 eta, rho solid minus rho liquid. Now let's look for the graphical variations. So the first thing is terminal speed is proportional to r square if rho solid and rho liquid are constant. So the graph will be parabola between terminal speed and r. If we look for the graph between Vt and r square, that will be a straight line. I assume that r square is equal to x. So that will be a straight line variation. And if I draw a graph between Vt and eta, the graph would be a rectangular hyperbola. So in this way you can solve your questions quickly. Always do remember, whatever information you learn, whether it's one word, one line, one para, one page or one book, make sure you learn it in a format, in a way that you are able to retrieve it as and when needed. You learn anything, but if you are not able to retrieve it when it is needed, then all the information are of no use. So work on quality of information and your quality of mind. Then you will be able to be successful in today's dynamic world. Thank you and have a nice day.